definition, stand-up philosopher. What? Stand-up philosopher. I coalesce the vapor of human experience into a viable and logical comprehension. Oh, a bullshit artist. Did you bullshit last week? No. Did you try to bullshit last week? Yes.
And as an add-on to this topic of the transmission line not with the reflected pulse not causing a change at the receiver or transmitter, here's the Megabucks laboratory grade Tektronix TDR, and here's the pulse on the left. That's the incident pulse from the pulse head going through this short cable out through 3 meters of cable pardon me, to a dummy lobe, a couple of connectors. Along that line at the top, we don't really see anything significant. It looks pretty much flat. If we sweep it out, we see a little artifact here. And when we increase the magnification and really sweep it out, we see that. Well, that's looking along the time that the signal's propagating along that transmission line. Is it a bad spot in the line? No. This is why we got to have good, tight coax connectors. The rules for these SMA connectors are they're supposed to be tightened with a special wrench. I've left these connectors loose. I've unscrewed the SMA and I've unscrewed and backed off the BNC. I can't do this all at once, but here's the view, about half a division wide, about a division high. Then after tightening them, the pulse on the left side's pretty much disappeared. That's why it's real important to have these connectors tight. Because what defines the outer conductor and the diameter of the conductors and the characteristic of the line is the end of that barrel pressing up against the inside there. It's not the screw threads and not this outer shell. Those are intended to push those two surfaces together in here. And if they come out of alignment or the energy has to travel out to this part down here, then that defines a different characteristic of connector. That makes a discontinuity. That doesn't look like much of a disturbance until you figure that step there is a kilowatt. And now a couple of crappy old connectors are putting several watts worth of RF trash in the ham shack with a receiver with microvolt sensitivity or some other sensitive equipment. But here it is with proper dummy lobe. And we see the incident pulse is 2 major divisions and 1 minor. That's 10, 20, 30, 40, 50. That suggests 50 ohms. When the dummy load's unscrewed and removed, that's an open-ended transmission line. And here, that first step on the left is where that little discontinuity was because of loose connectors. It's just that the sweep is much wider now to see the entire incident pulse. You can see there's still 10, 20, 30, 40, 2.5 divisions. That's 50 ohms there. Sweep it out a bit. But then where that second step is, that's the end of the cable. So here is where the end of the cable is. That's where that little blip was. We can't see it because the sweep's way out. Over there, actually this is the start of the pulse. This is the length of the cable. Notice the cable's about 1.5 divisions wide. That's how far in time it is. And the setting is sweeping it further out, and at 5 nanoseconds per vertical division, that's 5, 10, 15, 20, 25. The length of that cable is 28 nanoseconds long. This illustrates what the textbook said. Transmission lines operate in the time and distance. So there's the start of the TDR pulse from the pulse head going onto that line, that 3 meter line. It travels along that 3 meter line in 5, 10, 15, 20, 25, 28 nanoseconds. And the end of that cable is open, and there's a huge reflection. There's the reflection at a mismatched antenna, a grossly mismatched antenna. The cable's reciprocal. It'll be exactly the same amount of time out as it will back. There's no magic to it. So let's move this 1, 2, 3, 4, 5, 6 divisions towards the left and look and see what happens at the time. So just basically move it the entire half width of the screen over and see what that trace is doing at the time the pulse returns to the receiver. So the pulse is coming out of the pulse generator over this short nanosecond jumper, out this 3-meter cable that finds the open end. It comes back the same amount of time back to the detector input. So here is a dither that suggests that that's the input. I'll increase the gain here. Is at the same time. 1, 2, 3, 4, 5. It's the same time. So this is where the pulse has left that open end of the cable where the dummy load used to be. Let's come back to the sampling head. There's a little perturbation there that's minor. It's more than when the connectors were loose. You see there's this complex of 2 connectors and this detector inside. Do you see any subsequent reflection? This is a reflection over here. That's a reflection caused by the far end of the line, which would correspond with the antenna, causing a big reflection. Do you see this mythical pulse causing a big mismatch in the receiver? And this is the same thing as a radio receiver. This is the transmitter here, that's the receiver. It's just they don't happen at exactly the same time. Do you see any big step change like that indicating that the pulse was again reflected at the receiver? You do not. All you see is a little discontinuity from these cheap Chinese connectors and cables. A real cable set to really do this would be big bucks. I can't justify it. But I'll sweep this out further, further. A little change of magnitude. But there's no such thing as this magic discontinuity or mismatch at the load causing a change in impedance at the input. It's BS and myth. Okay, here's our original view. Far left, 0. The incident pulse stepping up there at about 3/4 division. At about 20, 40, 50 ohms, there's a link to that 50 ohm line. And then this huge discontinuity, which is another 50. That means it's the same energy coming back. It'll roll off here due to frequency losses. And now I'm going to show you what clamping a magical ferrite to the cable does. You know the ham myth about something about currents down the shield and ferrites and noise and all that crap? Now that's also a pile of horse manure. So I'll start with the open line case since it's already there. We know the length of that cable going out is there. So any effects on clamping the magic ferrite will happen in the 1 1/3 divisions going this way to that point right there. It'll be in here. There's a magic ferrite, layered suppressor core, HF suppressor core, excellent suppressor core. Anything change there? It did not. There's a forward trip, 1 1/3 divisions. The return trip, 1 1/3. There's a slight discontinuity here at the connectors. Nothing. And I'll take it off. You can see it again. Notice the sag in the waveform. Zip, not a nothing. Now I'll expand it out so we can see it better. Expanded the sweep from the rise at the left, 5 1/2 divisions to the right. So to the center and just a little bit to the left. See that little bobble there? That magic ferrite is at about the center graticule here. And while you're watching, I'm going to clamp it on. Nothing changed. This is the same view in the same location with the dummy load attached. You don't see the big step from the open transmission line. I'm going to snap the clamp on. Nothing happened. Okay, the proof. Proof that a reflection at the load causes a magic mismatch at source is a lie. I proved to you that that was a fiction created by the four authors to establish the notion of reflected power where it could not be established with a proper load. They did that for a reason, but then they go on and fix the problem. This is not ham myth. And they're full of you know what when they talk about their magic ferrite clamps. And this is not ARL, not MFJ, not Mickey Mouse. It don't get any better than that. So, laboratory. This setup was $50,000 in the late 1980s. This ain't toys. Real components, I know how to use them. These things that we've been taught are myths, BS, and in some case, lies to sell stuff. Anybody, almost anybody with a few bucks can afford a TDR. W2AEW shows how to, on YouTube, how to approximate this for the scope and the signal source. It's not quite the same, but it works. And scopes and signal generators are easy to get. But notice the people pushing these fairy tales never ever prove it. It's because, like when Chuck gets around making his video about his antennas, he spent $500 on magic antenna parts from people selling antennas claiming to be experts, and when it didn't work, he contacted them and found they know nothing about it. And boy, he was mad. So there it is. Absolute proof. KBYP did it.